And the dreaded Galilean thermometer, right? Not to scale. Okay, so the first thing they ask you to do is they say, use the graph to determine the buoyancy force acting on the sphere when the ethanol is at a temperature of 25 Celsius, right? So what you're going to do here is find 25 Celsius, right? And you're going to realize that if you go up and you go over, that the density is 785 kilograms per cubic meter, right? Okay. And then they also tell you that we can neglect the mass of the glass, right? Can be neglected, and we've got a radius of 3 centimeters, right? Okay, so you're going to use that the buoyant force is the density of the fluid being displaced, the volume of the fluid displaced, and G, right? The volume is going to be 4/3 pi r to the third, right? And you're gonna use that 785, right? Then it says when the ethanol temperature is at a temperature of 25 degrees, the 25 degree sphere is just at equilibrium. The sphere contains water of a density of 1,080 kilograms per cubic meters. Calculate the percentage of the sphere volume filled by water. Okay, so the first thing I did was I figured out the mass of it, right? The mass, it's just at equilibrium, right? So you're going to say mass is equal to the density of the ethanol, right? Which is 785, right? So I'll just put the number in there, 785 times the volume of the sphere, right? So 4/3 pi r to the third, right? Don't forget to convert the centimeters to meters, right? Okay, and then that will give you the mass of the fluid displaced, right? Okay. Then what you want to do is you want to figure out the volume of that, right? And the volume of that fluid is going to be, that's inside of this hollow glass sphere, right? There's going to be some amount of volume, right? Okay, we're neglecting the mass of the glass, right? Okay, so the volume is going to be this mass divided by 1,080, okay? And that's going to give you some amount of volume, right? So now we figured out the volume of this water. That's that volume. Okay, I'll call it volume of the water, okay? And then you have to figure out the volume of the sphere, if you haven't already done this, right? The volume of the sphere is 4/3 pi r to the third, right? Okay, and that's going to equal bloomp, right? So then the percentage of the sphere filled with water is going to be the volume of the water divided by the volume of the sphere, okay? And the answer is somewhere between 70 and 80%, okay? Between 70 and 80%. And then the last one, the last question says, the room temperature increases from 20 to 25 degrees Celsius, causing the buoyant force to decrease. From this change in temperature, the ethanol density decreases from 785.2 to 785.16, right? Okay, so here's how I did this. I figured out the change in buoyant force, right? The change in buoyant force is going to be the change in density, right, times the volume of that sphere times G, right? Okay. The change in density literally is 785.2 minus 785.16, right? And then the volume of the sphere is going to be 4/3 pi r to the third, right? And then G is going to be G, right? Okay, so figure out that change in buoyant force. That's the force that's driving it. And it's something 4 point something times 10 to the minus fifth newtons. And this is a downward force, right? Then that force, right, this is a force, a downward force, right? And then just set that force equal to 6 pi mu. We're using Stokes' equation, right? RV, right? So just plug that in, and they tell you the viscosity of the ethanol, so plug that in there. The radius of the ball is, 0.03 meters. The force is what you get here. This is that number that's 4 point something times 10 to the minus fifth newtons, right? Plug that in here. Solve for V. Happiness will be yours. Perpetual happiness for the rest of your life if you solve that, okay? I think anyway. I think that's how it works.